Welcome to math class. Today I will teach you application of calculus in economics and commerce. And commerce. In application of calculus in economics and commerce, you have to know first of all some basic terms. These terms are number one, cost function. Cost function we represent with this letter C or we write Cx. Okay. Then total functional cost we represent with TFC. Okay, and variable constant with V. Now cost function is equal to TFC plus V, or we write TF in C into V, sorry, plus Vx. Okay. Second term is your revenue function. Revenue function we represent with Rx, and P into X we write, where P is the number of, where P is the cost of articles, and X is the number of articles. Okay. Third one is profit function. Profit function we represent with Px. Okay, P stands for profit. Profit function is equal to revenue function, how much a person is collecting, minus cost function. If you subtract cost function from revenue function, okay, revenue function C or Cx. Okay, this is your cost function, this is your revenue function. If you subtract, you will get profit function. Okay. Now, break even point. What is the meaning of break even point in economics and commerce? Break even points. Break even points means this will be your equal to 0. Means there will be no profit and no loss. Okay. So Px equal to 0. That is, we can write at break even point, revenue function as well as total cost function are equal. Okay, so this is one of the important equation. Okay, when the business is running at no profit and no loss, means the total revenue collected will be equal to the total investment or total cost. Okay, next point is average cost function. Okay, ATC, average total cost. Okay, we represent with this capital letter ATC. And what is this? Average cost, average total cost is always equal to total cost divided by the number of articles. Okay, so this is another important equation. Okay. Then marginal cost. Marginal cost we represent with MC. Both are capital. Okay. Now here we are going to use calculus. Okay. To find marginal cost, if you find the derivatives of cost function, you will get marginal cost, or marginal cost with respect to the number of articles. Okay. Or moreover we can write dc by dx. Okay. Take one example, the cost of manufacturing. I am writing the question first. The cost of manufacturing of certain articles or items of rupees 1600. Okay, the cost of manufacturing of certain item is rupees 1600. Okay, and as overheads, rupees 30 per item. Okay. Okay, and the labor cost is rupees x square by 100 for x items. Okay, how many items must be produced to have minimum average cost? Minimum average cost. We are asked to find minimum average cost. So you know that total cost we will find first. Okay, total cost. Total cost will be your what? Total cost will be your this. Okay, cost of certain items 1600 plus 30x. Why 30x? Because overheads on each item, overhead expenses is 30 rupees. So if the company is manufacturing X item, so it will be your 30x. Okay, then and the labor cost will remain same. Okay, plus x square by 100. Okay, if x unit is producing, then labor cost will not change. If more is producing, then more labor will be required. In that case, labor cost will also increase. Okay, so this is total cost function. What we are getting? We are getting this. So everything we can write in like this bracket. That will be more better. Okay, because all are in rupees. Okay, then average cost. Average cost, that is AC. Okay, will be your what? This total cost divided by number of items x square by 100 divided by x. Later on, if you simplify, you will get your answer in this way. Okay, 1600 x plus 30, because x actually can cancel, and here we are getting x by 100. So this is your average cost. Now the question was, how many items must be produced to have minimum average cost? Okay, how many items must be produced to have minimum average cost? Okay, so now we will find the derivatives of this average cost. Okay, once again I have to write average cost, which is your 1600 plus 30x plus x square by 100 by x. It was like this, no? Okay. Now we have to find its derivatives. Okay, this we can represent with y also. There is no problem. So AC also we can write, or you can assume this is equal to y. Then it will become dy by dx with respect to number of items. Okay. So now if we find the derivatives of this, then what will we get? We will get like this: d dx of 1600 by x plus 30 will be outside, or here if you simplify then you will get 30. So d dx of 30 plus x cancel, 1 by 100 take outside because 1 by 100 is constant, and d dx of x. And if we simplify then we are getting here 1600 again outside, d dx of x to the power minus 1. d dx of any constant is always 0, and derivatives of only single x means 1. Okay. Moreover, if we simplify this, then 1600 minus 1 x to the power minus 1 minus 1. Okay, according to the rule of derivatives. And here we have 1 by 100. Okay, so what we are getting here, minus 1600 into x to the power minus 2 plus 1 by 100. Okay, so next, minus 1600 by x square plus 1 by 100. Okay, now for maximum or minimum value, okay, of production, okay, to minimize the cost, this must be 0 according to the rule of maximum minimum. Okay, property we have to use now. Okay, so we will write first for maximum or minimum value. For maximum or minimum value, okay, dAc by dx must be equal to 0. Okay, so now we will compare this with 0. Okay, minus 1600 by x square plus 1 by 100 equal to 0. So from here we are getting 1600 by x square equal to 1 by 100. Okay, and if you simplify, what will we get? We will get x square equal to 1600 into 100. Okay, then value of x will be your x equal to under root 1600 into 100. Here you know that according to the rule of square root, plus and minus should be there, but we will take only positive because no factory, no company can produce any negative number of items. Either the company or factory can produce 1 or nothing, something or nothing. Nothing means 0, but okay, negative production is not possible. So we have to write here positive. Next, what we are getting, x means if you take out this square root, then it will give you 40, and for this 10, that is 400, right? So 400 number of item, okay, x is your 400. Then we will go for second order derivatives test. For second order derivative test, again we have to find the derivatives of this, because this was the derivatives of first order. So second order means d square AC by dx square, and then we will write here ddx of minus 1600 by x square plus ddx of 1 by 100. Okay, next we will simplify. Further simplification will give us d square AC by dx square equal to, minus will be outside, minus 1600, then derivatives of this minus 2, that is minus 2 x to the power minus 3 plus 0. Why 0? Because this is a constant. Okay, then what we are getting next, dx square equal to minus minus plus, that is 3200. Okay, and this will come down, then it will become positive. Okay, now we had value of x as 400. Okay, so d square ac dx square at x equal to 400, what we are getting, 3200 divided by 400 cube, and this value is always greater than 0. Okay, it will be always greater than 0. If the second order derivative test is more than 0, that means, okay, production will be minimum. Okay, clear? Sorry, the cost will be minimum if the company will produce 400. Okay, minimum when this is greater than 0. Okay, and maximum when second order derivative is less than 0. This point, you have to remember this 2 points when you want to find maximum or minimum production. Okay, so thus we are getting this, hence we will make conclusion, hence, okay, there will be minimum average, or the minimum average cost, okay, minimum average cost of the production will be if the company produce, okay, will be when the company produce 400 articles. Okay, okay, clear? So in this way you have to use. Okay, so in this video this much only. Thank you.